So, let's go. You know Uranus as a punchline. Scientists know it as the planet that refuses to make sense. It rolls around the sun on its side. It's colder than worlds twice as far from the sun. Its magnetic field is so broken that physicists had to invent new kinds of matter just to explain it. And here's the part nobody tells you. Almost everything we know about this planet comes from 5.5 hours in 1986. One flyby, one bad day. That's it. So tonight you're going inside. Past the clouds that smell like rotten eggs, down through rain made of diamonds, into ice hotter than the surface of the sun, all the way to a core that might contain the wreckage of another world. 10 theories. Each one sounds fake. Each one might be true. Number 1, it rains diamonds. Start falling. 10,000 kilometers down, roughly the width of an entire planet below the cloud tops, the pressure around you passes 1,000,000 times. Anything your body has ever felt, and the temperature climbs toward 5,000 degrees. And here, something strange happens to the methane. Pressure rips the molecules apart, the hydrogen escapes, the carbon doesn't. It gets squeezed, atom against atom, until it snaps into the hardest structure carbon knows how to make. Diamond. And diamond is heavier than everything around it, so it falls. Not one diamond. A rain of them, sinking through the dark for thousands of kilometers, growing as they go. This isn't a guess. In 2017, scientists fired one of the most powerful lasers on Earth at a piece of plastic, a stand-in for the chemistry inside an ice giant, and watched through X-ray eyes as nearly every carbon atom in it snapped into nanodiamonds in a few billionths of a second. They recreated the inside of Uranus in a lab in California, and it rained. Then it got better. A follow-up experiment in 2022 used a different plastic, literally the stuff soda bottles are made of, and found that oxygen makes diamond formation easier, which means the rain probably starts shallower, falls longer, and grows bigger than anyone thought. Some estimates put the falling diamonds at millions of carats. Your engagement ring is one. And the bottom of that rain might be the strangest part. Lab measurements show that at pressures near the core, diamond melts, and liquid diamond is denser than solid diamond. Solid chunks would float. Somewhere beneath you, there might be a black ocean of liquid diamond with diamond icebergs drifting on top of it. The planet everyone laughs at may be the most valuable place in the solar system, and the diamonds are the least weird thing down here. Number 2, black hot ice. Forget what the word ice means. The ice inside Uranus is black. It's hotter than the surface of the sun, and it's solid and liquid at the same time. It's called supersonic ice, and it works like this. Take water, crush it to millions of atmospheres. The oxygen atoms give up and freeze into a rigid crystal lattice, a solid. But the hydrogen doesn't freeze. The protons tear loose and flow through the solid oxygen cage like a river running through scaffolding. The water is frozen and flowing simultaneously. It conducts electricity like a metal, and calculations say it only melts above several thousand degrees. For 30 years, this stuff existed only in equations. Then, in 2019, researchers in New York focused 6 of the world's most powerful lasers onto a single droplet of water. For 1/1000th of a second, the droplet became the inside of an ice giant, and X-rays caught the oxygen lattice locking into place. Ice 18. Black hot ice, real on Earth, for a nanosecond. Inside Uranus, it isn't a nanosecond. Models suggest most of the planet's interior is made of this, a vast supersonic mantle that behaves less like an ocean and more like Earth's deep rock, solid but slowly flowing over geological time. You are not falling through a sea down here. You're sinking into something that hasn't decided what it is, and here's the thought that should keep you up tonight. Ice giants are the most common type of planet we've found in the galaxy, which means this black, scorching, impossible ice might be the default state of water in the universe. The stuff in your glass is the exotic version. But if most of this planet is locked solid, that creates a problem. Because something inside Uranus is missing. Something big. Number 3, the heat that vanished. Every giant planet is still cooling down from its birth. Jupiter radiates nearly twice the energy it gets from the sun. Saturn does too. Neptune, farther out, smaller, dimmer, still glows with about 160% of what it absorbs. The heat of formation leaks out for billions of years. That's just what planets do. Uranus measured at basically 100%. Nothing extra. For 4 decades, every measurement said the same impossible thing. This planet is dead inside. That's not a small problem. A planet 14.5 times the mass of Earth doesn't just misplace its formation heat. Yet there sits Uranus, with the coldest atmospheric temperature ever recorded on any planet, about minus 224 degrees Celsius, while Neptune, 50% farther from the Sun, runs warmer. Something either stole this planet's heat or something is holding it prisoner. Then, in 2025, the case cracked open. Researchers went back through decades of telescope records. Not one snapshot, but the planet tracked across its seasons, which take 20 years each, because a year on Uranus lasts 84 of ours. And buried in all that data, they found a pulse. Uranus does leak internal heat. About 12.5% more energy comes out than goes in. So the planet isn't dead. It's barely breathing. 12% against Neptune's 60% nor. That's not an answer. That's a smaller mystery wearing the old one's clothes. The heat is still in there, sealed behind something. A wall, a lining. Some structure deep inside this planet is working like the world's largest thermos. Keep that locked door in mind. 3 of the next 4 theories are about what's standing behind it. Number 4. The magnetic field made in a thin shell. Earth's magnetic field is polite. It lines up with the planet's spin, give or take 11 degrees, and it's anchored at the center. Compasses work. Auroras stay near the poles. Everything behaves. Uranus looked at all that and said no. Its field is tilted 59 degrees off the spin axis. It's not even centered on the planet. It's shoved 8,000 kilometers to one side, which is more than the entire radius of Earth. One hemisphere gets blasted with magnetism while the other barely feels it. And because the planet spins every 17 hours, that lopsided field doesn't rotate so much as tumble. Researchers who simulated it describe the whole magnetosphere cartwheeling end over end like a child rolling down a hill. It gets worse. Modeling suggests the field's protective bubble tears open and snaps shut against the solar wind every single day. Earth's shield is a fortress. Uranus's shield is a strobe light. Why? The best answer is that Uranus's field isn't made where Earth's is. Earth's dynamo churns deep in its molten core. But remember what's inside Uranus. That vast superionic layer locked too stiff to churn. The only place where conducting fluid can move freely is a relatively thin shell of electrified water near the top of the mantle. A dynamo running in a thin shell instead of a deep core naturally makes exactly this kind of field. Off-axis, off-center, messy, multipolar. And in 2026, simulations added a new suspect, an in-between state of matter where hydrogen streams through channels in a rigid carbon lattice, not solid, not liquid, something with no everyday name. The planet may be built from substances we're still inventing words for. There may have never been a true north on Uranus, just a field with no fixed address, wandering forever. And the reason for all of it might be a single moment of violence 4 billion years ago. Number 5, there might be another world buried inside it. Uranus orbits lying on its side, tilted 98 degrees, rolling around the sun like a ball instead of spinning like a top. Each pole gets 42 years of daylight, then 42 years of night. No other planet does this. Planets don't just tip over, unless something tips them. In 2018, researchers ran more than 50 supercomputer simulations of the early solar system, smashing virtual worlds into a young Uranus over and over, looking for the version that produces the planet we see. The best fit? A protoplanet made of rock and ice, roughly twice the mass of Earth, delivering a grazing blow about 4 billion years ago. Not a head-on kill shot, a glancing hit, hard enough to knock a giant planet permanently onto its side, gentle enough to leave its atmosphere intact. Now ask the obvious question. Where did the impactor go? The simulations have an answer, and it's the unsettling one. Some of that dead world's debris likely spread into a thin shell deep inside Uranus, draped near the edge of the ice layer. A layer of foreign wreckage, which happens to sit exactly where you'd want insulation to explain the missing heat from number 3. The thing that knocked Uranus over may be the same thing keeping it cold, and the impactor's dense core wouldn't have bounced away. It would have sunk, merging inward, settling somewhere near the center, which means when you point at Uranus, you might be pointing at two planets, one wearing the other, a world that died 4 billion years ago, buried inside the body of the world that survived it. The crime scene doesn't end there, because when scientists try to map the layers of that burial, the layers refuse to exist. Number 6. The core isn't a core. Pas plant. Picture the diagram from every textbook. Atmosphere on the outside, icy mantle in the middle, rocky core at the center, clean rings like an onion, with neat boundaries between each one. Now throw it away. It's probably fiction. Here's the problem. When scientists build a model of Uranus with clean layers, it breaks. A layered Uranus can match the planet's gravity, or its feeble heat, or its broken magnetic field, but not all three at once. The numbers refuse to cooperate. Something about the picture is fundamentally wrong. The models that actually work look much stranger. No boundaries at all. Rock, ice, and gas smeared into each other in one continuous gradient, heavier toward the middle, lighter toward the top, with no line where one ends and the next begins. Not an onion. A planet-sized smudge. Scientists call it a fuzzy interior, and the only place anything like it has ever been confirmed is Jupiter, where a spacecraft measuring its gravity found a core that isn't compact at all, but diluted, blurred halfway out into the planet. And a fuzzy Uranus would quietly solve the heat crime from earlier. Heat escapes a planet by convection, hot material rising like soup boiling. But a compositional gradient kills convection. Each level is just heavy enough to refuse to rise. The whole interior becomes a stack of sealed floors with no staircase. A built-in thermos lining, planet deep. Recent models add one more twist. Deep inside, water and hydrogen may have separated like oil and vinegar, layers that physically cannot mix ever. The inside of Uranus may not be a structure at all. It may be a substance war, frozen mid-battle, 4 billion years, and counting. And if the layers are up for grabs, so is the ingredient list itself. Number 7. The hidden methane layer. We call Uranus an ice giant because we're confident it's mostly water. Here's an uncomfortable question. Based on what? No probe has ever gone inside. The water story is an assumption, a reasonable one, decades old, baked into every diagram. In 2024, a group of researchers decided to test it properly. They built hundreds of thousands of computer models of the planet's interior. Not a handful, hundreds of thousands, each one a different recipe, each one checked against the planet's real mass, size, and gravity. Then they looked at which recipes actually produced the Uranus we measure. The winners had something odd in them. A thick hidden layer rich in methane, possibly frozen solid, possibly a slush, wrapped between the hydrogen envelope and the watery deep. Not a trace of methane. A planetary scale reservoir of it, billions of times more than anything Earth has ever burned. And there's a clean story for where it came from. The building blocks that formed Uranus were probably carbon-rich, tar-black, organic-heavy chunks from the cold outer dark. Crush those together with hydrogen during the planet's birth, and chemistry does the rest. Carbon plus hydrogen, cooked under pressure, manufactures methane in bulk. The planet wouldn't have collected its methane layer, it would have made it. A world that synthesized its own fuel reserve and then buried it. If this is right, the most basic fact about Uranus, what it's made of, has been wrong the whole time. It's not a water world wearing a gas coat. It's something we don't have a proper name for yet. And the deceptions aren't just deep ones. Even the weather up top is hiding something from us. Number 8. Mushballs. Point a radio telescope at Jupiter and you'll find ammonia, one of the basic ingredients every giant planet inherited from the cloud that built the solar system. Point it at Uranus and the ammonia is just gone. The planet has plenty of methane, plenty of everything else. But one ingredient is missing from the visible atmosphere, like a word deleted from every page of a book. The leading explanation sounds like a joke, and it's called exactly what you hope: mushballs. The mechanism was worked out at Jupiter, where a spacecraft found violent storms doing something nobody predicted. Water ice gets thrown high into the atmosphere. Ammonia finds it there, and ammonia is antifreeze. It melts the ice on contact, even at temperatures that should freeze everything solid. The result is a slushy ball of water ammonia mush that gathers more ice as it's thrown around the storm, layer after layer, like a cursed snowball, until it weighs a kilogram or more, bigger than the largest hailstones on Earth. Then it falls, and it keeps falling, below the storm, below the cloud decks, down to depths where no telescope can see. The ammonia doesn't escape back up. It's kidnapped, hauled into the deep, and locked away beneath an opaque ceiling. At Uranus, the chemistry says this should work even better. The mushball zone runs deeper, the slush falls farther, basketball-sized hailstones of ammonia mush, sinking through black skies, smuggling a planet's worth of evidence below the floorboards. The atmosphere of Uranus isn't just weather, it's an active cover-up. The planet eats its own clues, which is somehow still not the most insulting thing its atmosphere does. Number 9. The clouds smell like rotten eggs. This one isn't a theory. This one is confirmed, peer-reviewed, telescope-verified science. Uranus smells like rotten eggs. For decades, nobody could settle what the planet's cloud tops were made of. Even the flyby in 1986 couldn't answer it. Then, in 2018, astronomers using an 8-meter telescope on a Hawaiian volcano pulled apart the infrared light coming off the planet and found the fingerprint they'd been hunting for. Hydrogen sulfide. The exact gas that gives rotten eggs their smell, drifting through the cloud deck of an entire world. The scientist who led the work helpfully noted that if you ever fell in, the smell would be the least of your problems. The minus 200-degree cold would kill you long before the stench registered, but play it out anyway because the descent is worth feeling. You fall through the stink layer, it's gone in minutes, and now you're waiting for the landing, and here's the thing. There is no landing, there's no surface anywhere on this planet. No ocean to splash into, no ground to hit. The air around you just thickens. Gradually. The gas becomes haze, the haze becomes fluid, the fluid becomes the hot, dense dark you've been touring this whole video, and at no point is there a line you cross. You don't land on Uranus, you dissolve into it. The planet doesn't catch you, it absorbs you, somewhere on the long fall between the fart clouds and the diamond rain, a planet that smells like a prank and swallows people whole. And now it's time for the last item, the one that puts everything you just heard on trial. Number 10. The flyby that lied. Every theory in this video stands on the same foundation. One spacecraft, one visit. January 24th, 1986, Voyager 2, 9 years out from Earth, gets 5.5 hours of close observations as it tears past Uranus. 5.5 hours for a planet whose year lasts 84 of ours. Every textbook, every diagram, every fact about this planet grew from that single afternoon. In 2024, scientists went back through that 38-year-old data and they found something nobody had noticed. Days before the Voyager arrived, the sun fired off a surge of solar wind that slammed into Uranus and crushed its magnetic bubble down to 1/5 of its normal volume. The probe didn't photograph a normal planet. It caught Uranus mid-flinch, in a squashed, emptied, electron-blasted state that the team calculated exists about 4% of the time. Arrive a few days earlier, and the textbook Uranus is a completely different world. We rolled a 25-sided die once in 4 decades, and we hit the freak face, and then taught the freak face to every student on Earth. And here's the twist hiding inside the twist. The normal Uranus is more interesting. The flyby famously found a weirdly empty magnetosphere. No plasma, none of the water ions you'd expect if the moons were doing anything. That emptiness was probably the storm's doing, which means the moons, Miranda, Ariel, might be active ocean worlds, venting water into space right now. And the one probe we ever sent had its evidence stolen days before it arrived. And this is the turn, so let's say it plainly. The line between the confirmed science and the wild speculation in this video was always thinner than it looked, because even the confirmed half rests on one bad snapshot. An orbiter mission is now NASA's top-ranked flagship priority, and if it flies, it reaches Uranus sometime in the mid-2040s. Until then, the punchline planet keeps every secret it has. We judged an entire world from one drive-by photo taken during a storm and called it a textbook. Somewhere out there, the diamonds are still falling through the black, whether we ever go back to watch or not.